Very good evening, friends. So today this is your second chapter of biomechanics module, and we are going to study about reference systems and terminology. So in biomechanics we have certain set of reference systems and some terminologies you should know so that we can pinpoint our movements and describe our movements in analysis. So after this, these are the learning outcomes you will be getting out of this lecture. So the participants will understand reference system used in the biomechanics. Number 2, you will become very familiar with directional terms. And number 3, participants will understand reference planes and axes used in biomechanics for describing various human movements. And number 4, you will be able to utilize above terminology which we will learn today for describing specific movements in sports, because it is just like a language. When you express, you need language to communicate your message, right? Similarly, in biomechanics we use these terminologies, these terms, these direction terms, to specify, to pinpoint our different points on the body, or to specify or name certain movements. And this is universal language of biomechanics. You should know this. So when you are talking in biomechanics, you are discussing some analysis, you need to know these terms. Otherwise you won't understand what we are saying, what biomechanical scientist or biomechanist is saying to you. So you should know that. Okay, so all these outcomes will come after this video lecture. Okay, now first of all I'll let you know a standard reference terminology in biomechanics. So what is that? Communicating specific information about human movement requires specialized terminology, as I discussed before, that precisely identifies body positions as well as directions. So using this reference terminology, you will be able to identify different positions you take during different movements, okay, and also in different directions. So this is a medium to express the names of your movements, to specify movements, to specify body positions. So this is a standard reference terminology. And first of all, in this we have anatomical reference position. So what is that? Just look at the figure on the right hand side. This is the position I am talking about. This is known as anatomical reference position, and this one is the most preferred one, position in which we do the we can study different body positions. And so what is that position? Basically, if you want to define it, it is basically anatomical position. Anatomical reference position is an erect standing position with the feet slightly separated and the arms hanging relaxed at the sides, but the palms of the hands facing forward. Concentrate on palms. So when the palms are facing forward, this is the key point here, which will define it as a anatomical reference position. And if these are not facing forward and they are in the sideways, like normally you have seen many times, right, like standard ease and attention position, so that is standard position. So these are the two reference positions we have. So I am focusing more on this one because this is the one which is usually taken in account when we are discussing these kind of terminologies. So it is known as anatomical reference position. Okay, so this is the first term you should always keep in mind, and you should know the difference between the anatomical reference position and the standard reference position. In standard, these palms are on the sideways, like standard like attention position, right? But this is the preferred one because this allow us to study different position in a better way, because you can see that every joint and every angle is clearly visible in this position, and when we do analysis and all that, so this is more favorable position. Okay, so the point is clear, I think, from this slide. Now coming to the directional terms. So these are the terms which you should know because these describe the relationship of body parts or location of an external object with respect to the body. Okay, when you are defining something, some body part, then you should use these terminologies so that you can pinpoint and specify the point or the body position you are talking about. And it is very essential in biomechanics and in anatomy also. If you are coming from the medical background, there also same terminology is used, but because we are dealing with the bio and mechanics, and so the bio part is there, so that's why you should know these terms and try to utilize these terms. When you use it like a language, you will definitely, it will automatically come into your brain, right? So first term is superior. Superior means closer to the head. Just concentrate on the figure on the right hand side, the human body. So the first arrow is towards head. So superior means closer to the head. Now, for example, eyes are superior to the head because they are close to your head, right? So this is the example. You can, in this way, if you describe things, so you will definitely going to understand this. Inferior is away from the head, right? So your stomach is away, is inferior basically. If you use that terminology, your stomach is inferior. However, eyes are superior. So what does mean? That eyes are closer to the head, and your stomach is, or your abs muscles, your abdominal muscles are away from the head. So this is, I think, clear. Superior and inferior. Then anterior and posterior. Anterior means towards the front of the body, on the front side. Heart is anterior organ, right? So this is anterior. What is posterior? On the back side. Spine is posterior, back side of the body. So it is also clear now. Now proximal and distal. Proximal means closer to the trunk. Trunk is your abdominal region area, right? So the thighs, thighs are proximal to the trunk, are proximal body part because it is closer to your trunk. What is distal? Which is away from the trunk. Ankle is distal because it is away from your trunk. So this is the way you should utilize, and try to have this kind of activity between with your friends and try to use these terminologies. Then you will very quickly grasp this in your day-to-day language, and then it will be very easy to understand the things. Superficial and deep. So what is superficial? Superficial means which is towards the surface of the body, which you can feel, like you have biceps, your skin, you can touch that. The things which you can touch or feel is superficial. So biceps are superficial, your skin is superficial, okay. And what is deep? Which you cannot feel from outside. What is deep? The abdominal muscles inside, right? The organs are deep. So this is the directional terminology which we utilize. I think it is very clear and it is very simple. The only thing is when you utilize it, then you can understand it in a very good way. Now another directional terms is there with respect to midline. So these are two terms. One is medial, that means towards the midline, and second one is lateral, away from the midline. So here is the diagram which will clearly make you understand. So you can see the line, black line going right here. You can see that the line which is going from the middle of the body. So this is the line. So this line is midline. So what is medial? Which is towards the midline. See this one. So when the arrow is towards the midline, so that means medial, and when we are talking of movements away from the midline, so that is lateral, right? So this is the way you can do. So this is the example. Now this is the shoulder lateral workout. In this way, what are you doing? You are taking the dumbbells away from the midline. So this movement is known as lateral movement. What you are doing? You are taking the dumbbell or this body part away from the midline. So this is the way. These are the two additional terms which are with respect to midline. I think it is very clear now. Moving to the next slide. Now, after these two terminologies, we have anatomical reference planes. These are also known as cardinal planes. So what is the use of this? They are very useful in the biomechanics because these help us to again pinpoint different movements which we do. Up till now, what we have studied is to locate something, locate certain body part. Now these reference planes help us to classify movements which we do. So in this lecture I am not going to touch the movement will be touched in the next class, but in this class, in this lecture, I am just telling you the terminologies, right? So anatomical reference planes, what are these? These are the three imaginary cardinal planes. So there are three in number. Always remember, three imaginary cardinal planes which bisect the mass of the body in 3 dimensions. So it will help you to pinpoint movements in the 3D because there are 3 planes. I'll make it very clear, you will understand what are these planes. The way I am telling you, go like that. You will never get confused because I am going to tell you a very simplest way to understand them or to learn them in your mind. The way I am telling, just go through like that, then you will automatically learn these planes. Otherwise they become very confusing, but I'll let you know very simple way. So first of all, I'm just letting you what are these. So each anatomical plane is an imaginary plane which divides the body, human body, into 2 parts. Each plane divides the body into 2 parts. Number 1, remember this in your mind. Plane will divide the body into 2 equal parts in order to describe the location of structures and the direction of the movements. So this is the purpose. So anatomic plane is what? It is a 2-dimensional plane which will cut your body into 2 parts. So what is the purpose? To describe the location of the structure and to describe the direction of the movements, right? So 2 points are associated. The purpose is to describe the movement or describe the location, and how we do it? By dissecting the body into 2 parts. So how many we have planes? Up till now the message is we have total 3 anatomical planes or cardinal planes, and each of these 3 planes will divide the body into 2 parts, equal parts. And what is the purpose? The purpose is to describe the direction of the movements and to describe the location of the structures, right? So third point is again additional information. Reference planes are useful in describing gross body movements and in defining more specific movement terminology. Okay, so it is more concerned with the movements. So now from the next slide you will get to know what are these. The first plane is your sagittal plane, number 1. Now this sagittal plane, first of all, when you want to learn this, remember only one name because they have multiple names. Like sagittal is also known as anterior posterior, so don't go into that initially. Just remember sagittal plane. Okay, so sagittal planes divides the body into 2 parts, and these two parts are left and the right. Just see the figure. So you can see here, so this plane, 2-dimensional plane, is your sagittal plane. So when you insert inside the body, it will cut the body from here in this way. So in this way, left side and right side, in the 2 halves it has cut the body. So sagittal plane is what? The plane which cuts the body into 2 parts. What 2 parts? Left and right. This is the only thing you should remember to understand this. Sagittal plane cuts the body into 2 parts. What 2 parts? Left and right. Up till now, remember this. You got it? This is the sagittal plane. It is cutting the body into 2 parts, left and right. Right? Now, so what is frontal plane? Number 2. The frontal plane will also cut the body into 2 parts, but in this, the body parts are, we will move this plane like this so that we can divide the body into front and back. Now see, we have made the cut from the here, and it is parallel to the screen which you are watching. So when we cut the body like this, we'll have front part and the back part, anterior part and the posterior part. So this plane is known as frontal plane. Okay, it is also known as coronal plane, but don't get confused initially. Just remember the frontal plane. Frontal plane cuts the body into front and back, and in the terminology terms, frontal plane cuts the body into anterior part and the posterior part. Okay. Now third plane is your transverse plane. It is also known as horizontal plane. Now in this way, here you see the body, and now we'll pass this plane right from the middle of the body, so that we can cut the body into two equal parts, and these two equal parts are upper part and lower part. Okay, so this is the third plane. So all three imaginal cardinal planes, now together you can see that. So first of all, sagittal plane, which cuts the body into left and right. Then we studied frontal plane, that cuts the body into front and back. And third one is your transverse or horizontal plane, which cuts the body into up and below. Now focus on these colored planes. These are the planes which we are talking about. These are imaginary cardinal planes, right? Pink one, green one, and the blue one. An individual standing in anatomical reference position, the three cardinal planes all intersect at a single point known as body's center of mass or center of gravity. So in terms of these imaginary planes, when these three cross, and there is one point where all three intersect like this, so that point is known later on. So here is the point where all these three planes, what planes? This pink one, green one, and a blue one, sagittal, frontal, and horizontal plane, are intersecting almost about this point, and this point is known as center of gravity or center of mass. I will have full lecture on this point because it is very important in biomechanics later on, but for sake of these planes, if you want to define in the terms of these planes, so this is the definition, always remember it. So in terms of anatomical planes, what is your center of gravity? The point where these three planes cross each other, intersect. Okay, these imaginary reference planes exist only with respect to human body. Always remember this. And if person turns at an angle, for example to right or to any angle, if the body turns, these also get turns with that body. So what you get from this, what is the message here, is that these planes are not fixed. It moves when the body moves. If body tilts right, they will become right, they will also tilt right side. If the body turns left, so these are not fixed ones. So this reference system, cardinal reference system, is not fixed. This is very crucial point, you should always remember. And there is a reference system we have which is fixed one, that is also utilized in analysis. So these two systems are different, always remember it. I'll come to that later on. So important point about this imaginary cardinal plane system is that here the reference system is movable. It moves with the body, it is not fixed. That is the question, that is the main point, the main message on this slide. Two main messages about the cardinal plane is, one is what is the center of gravity, the point where they intersect. Number two, these planes are not fixed and they move with the body. So this is the only message from this slide about these planes. I hope it is very clear. Now an example, I am not talking about in detail in the movements in this lecture, just to understand, just for a sake of example. So here you can see this plane, you see this. So this plane is cutting his body into two parts, and that two parts are left and right. So that means this is sagittal plane, and this movement is parallel. See, cycle is parallel to this plane, so that means cycling is sagittal movement. Okay, this is just an example. I'll go in detail in the next class regarding movements. So this is just to give you example why we are doing this. So in this way we have pinpointed, if somebody is saying that he is doing sagittal movement, so that what that means, that movement is parallel to the sagittal plane, and you know it, what is sagittal plane? Sagittal plane is the one which cuts the body into left and right. So usually in sagittal planes we have forward or backward movements. So cycle is moving forward, or either if it is going backward also, it is the same thing because it is parallel to your sagittal plane. So in sagittal plane we have only forward or backward movements. So I'll come to this in the next lecture. This is just an example. Okay. Now, anatomical reference axis. So up till now we talked about planes. Now I am talking about axis. So we have talked about 3 planes. Similarly, we have 3 axes. So what is the purpose of these axes? So axes are lines, basically lines that pass from those planes. From each plane there is one perpendicular line that will pass from the center. Like from sagittal plane there is one line, from the frontal plane there is one line, and from the transverse plane there is one line, and these lines are axes. So when a segment of the human body moves, it rotates around an imaginary axis of rotation, and that passes through a joint to which it is attached. So this axis is the line around which rotation is there, and this line is always perpendicular to the plane. Like we have 3 planes: sagittal, frontal, and longitudinal. You know that. Similarly, from each plane, when a imaginary line will pass, that line is known as anatomical reference axis. So similarly, when we have 3 planes, so similarly we have 3 axes. So there are 3 reference axes for describing human motion, similarly like planes, and each is oriented perpendicular to one of the 3 planes. Now here's a trick I am telling you so that you can remember it. Once you understand all 3 planes, then go for axes. Now these are vice versa things, like this. Like from frontal axis will always be perpendicular to the sagittal plane. You know the sagittal plane? Sagittal plane will have always frontal axis, number 1. Number 2, frontal plane will always have sagittal axis. So these are vice versa. So once you know what is sagittal plane, just remember that sagittal plane divides the body part into left and right. Now in the sagittal plane, if you insert a line in the right in the center, so that line will be in the frontal area, frontal line. That will be in the frontal direction. The figure will make it more clear. So what you have to remember, in sagittal plane there is always frontal axis, and in the frontal plane there is always sagittal axis. It is like that, no matter what. Remember that. Okay, in this way you will understand it in a good way. And the third one is your transverse or horizontal plane. It will have always vertical axis. So once you understand these 3 planes, these axes automatically come into the picture. Just you have to remember that sagittal has frontal and frontal has sagittal. So these 2 are very easy to understand or to learn. And number 3 is your transverse plane, that will have vertical axis. Now in the next slide you will understand what I am saying. So these are the 3 axes. Just concentrate now on the arrows. This red one, this green one, and this blue one. Okay, and that black and white one is your plane, which we have discussed in the earlier slides. 1, 2, 3. Now you all know this plane. Now this first of all I'll make you revise. So this plane is cutting the body into left and right. So this plane is sagittal plane. So what I have told you, in sagittal plane there is always, when line passes through it like this, the red line is crossing this plane right from the center. So this is your frontal axis, right? Sagittal will always have frontal axis. See, frontal. So these are the axes which I have mentioned, and here is the colored line which is making it very clear. So sagittal plane has frontal axis, right? Number 2 we have, now this plane is cutting, just concentrate on the black and white, it's cutting the body into upper and lower part. So this means it is transverse plane, and right from the center the green line is passing. So this line, I have told you that in this transverse it will always be a vertical or longitudinal. So it is known as vertical axis, right? And again we have now third one, just concentrate on the black and white. So what is there? This plane is cutting the body into front and back, and from here when the blue line is passing through the center, so this plane is your frontal plane, and in frontal we have sagittal axis, so we call it as sagittal axis. I hope it is very clear. Just go through it 1-2 times, you will definitely understand. Just focus on the planes, axis will automatically come into your mind when you remember these points. Okay, I hope it is very clear now. Now coming to the last section of this video lecture is your spatial reference systems. Up till now we have talked about the things which can move. Anatomical planes move with the body, anatomical reference axis move with the body, but we need to have something which is fixed to pinpoint something. So for that we need spatial reference systems. So this is the difference. This reference system is fixed one. The earlier one is movable. This one is fixed, right? So anatomical reference system changes with change in the body. So here I am just revising that system changes. So we need some fixed reference system for location of points on the body. In the analysis we need that. We need that system so that we can pinpoint, and that should not move when the body moves. It should remain fixed. So for that we need spatial reference system, and the most popular and the mostly used fixed spatial reference system is Cartesian coordinate system, in which units are measured in the directions of either 2 or 3 axes. So this is very simple. So this system is the fixed one to locate the body parts or body points during the analysis, and this does not change when the body moves. For example, just concentrate on this. So here I am locating a point on the hip, and this point is, if you want to pinpoint it, this point you want to mark it, you just measure x and y. So here we have x axis and we have y axis. So what is the location? In x we have 3, 1 2 3, so like this, and on the y axis it is covering 7 points, 1 2 3 4 5 6 7. So the position of this point, if we want to fix it and we don't want to move it, no matter body moves or not, we will record that xy equal to 3y7. Now we have recorded this is the fixed point, and whenever we want to do analysis on this position again, just we have to fix this body again like this. We have to count 7 here and 3 here, and we'll get the same position again. So this is the use of this Cartesian coordinate system, and it is also known as spatial reference system, which is fixed one. Okay, I think it is very clear now. Now some additional points about these spatial reference systems. In 2-dimensional, when we are talking of 2 dimensions, then we have only x and y, and if we are talking of 3-dimensional, then another x with additional another axis comes, that is z axis. Then we talk in terms of x, y, z. Okay, the point of interest are usually the body joints, which constitute the end points of the body. Usually we fix these points on the joints of the body during the analysis. Okay, so when a movement of interest is in the 3-dimensional, then we have another z axis, that is the x, y, z. Otherwise we'll have 2 x or y. So this is the way we can do the analysis, and we can pinpoint the point. So this is it for this class. I hope you understood, and now you please go through assignment like I have given you and proceed to the next lesson. Thank you.